Hello students, welcome back in the video lecture. We have already started the chapter name Errors in Quantitative Analysis and the different aspects regarding this chapter we are discussing, learning from last few days. Okay. Now today we have to learn, today we have to see one of the most important aspect, and that is known as significant figures. The title is Significant Figures and Computation. We will see computation later on, but let us focus on significant figures. So what is meant by significant figures? The meaning of significant figures means numbers. The meaning of significant is meaningful. What is the meaning? Meaningful. Meaningful. Significant figures means meaningful figures. So we come across number of measurements in the analysis. These analysis may be in maybe of weights or masses, we can say, then lengths, then any analysis we can say. Okay, so to express these figures, to express these numbers, how many numbers are valuable, how many numbers are significant or meaningful, to express that result, that is known as significant figures. That is known as significant or meaningful figures. To express any number, what is a meaningful number or what is the meaningful figures of that particular number is known as significant figures. So let us say the definition. So the definition is very easy, and it is defined as a number of number of digits necessary to express or to denote, number of digits necessary to express or denotes that result or value in measured precision. So this is the definition of a significant figures. So it is defined as the number of digits, how many digits, number of digits, 1, 2, 3, etc. necessary to express or denote that result or that value in measured precision. Okay, so we are measuring the values, we are obtaining the results, and to express that result, mind well, to express that result, how many numbers or how many digits, let us say, instead of number we can use here digits. How many digits are necessary to express that result? Minimum number. That minimum number is called as significant figures. Okay, so the definition is quite critical or complicated, let us say, but if we go through the number of examples, then it is very easy to understand the definition as well as the concept of significant figures. Okay, so we will see the number of rules necessary to express or to identify the significant figures of any number. Okay, so let us see. So the rules are there. So the first rule is very simple. All non-zero numbers in non-zero value, all non-zero numbers in non-zero values, all are significant, all are significant. Okay, so all non-zero digits or numbers, all non-zero numbers or all non-zero digits in any non-zero number are significant, are significant, are significant. Okay, so let us take some examples. For example, 1 2 3 4, 1 2 3 4, this is a non-zero number. Okay, this is non-zero number and all the digits are non-zero, all the digits. So this digit is 1, this is 2 digit, this is digit 3, this is digit 4. I am not saying that they are sequentially 1 2 3 4, but the value of this is 4, value of this is 3, value of this is 2 and value of this is 1. Okay, so all are non-zero, so that's why significant figure of this number is 1 2 3 4. All numbers are significant, 1 2 3 4, all numbers are significant. So the significant figure is 4. This 4 is not this 4. Total number of digits 1 2 3 4, so these 4. Okay, you can write the you can take another example, 7 3 2 8 again. So how many numbers are there, how many digits are there? 1 2 3 4. This is non-zero number, this is non-zero number and all digits are non-zero, all digits are non-zero. So again all these numbers, all these digits are significant. Okay, we cannot omit or we cannot neglect any number out of these 4, 1 2 3 4. So all digits 1 2 3 4, this 7 3 2 as well as this 8 number, 8 digit, all are significant. So the number of significant, so the significant figure of this number is again 4. Okay, let us take one more, the 5 3 6, 536, 536, this number is 536. Okay, so this is non-zero number, all digits are non-zero, so this 5 is significant, 3 is significant as well as 6 is significant. So that's why significant figure of this number is 3, is 3. Okay, this 3 is not 3, 1 2 3, all these 3 digits are significant, so that's why significant figure is 3. Okay, let's take some more examples. For example, here 28, so this is non-zero number, then this is also a non-zero digit, all both the digits are non-zero, so this is also significant, this is also significant. So what is the significant figure here? 2, 1 2. Okay, then let's check in some cases. If you are reading such as 0.25 ml, okay, 0.25 ml. Now so this is not a non-zero number, this number is not a non-zero number. Okay, and all non-zero digits are significant. So in this case this 0 is not significant, this 0 is not significant, this 2 and this 2 5, this 5 is significant. So the number of significant figures in this case is 2. Number of significant figures in 0.25 ml is 2. This 0 is not significant, this 0 is not significant because this 0 is used here only to denote the decimal point, only to denote the, or only to express the decimal point. So that's why this 0 is not significant. These 2 and 5, these are two significant digits. So that's why number of significant figures in this case is or are 2. Okay, then 0.376. Okay, so this is a non-zero number. This is this digit is 0. This digit is 0. So it is before the decimal point. This 0 is before the decimal point, and hence it is non-significant. This 0 is non-significant. But 3, 7, 6 all are significant. So 1, 2, 3. So the significant figures in this case are 3. Okay, so this is a very first rule, that is all non-zero digits in any non-zero number are significant. They are significant. Okay, so this is the very first rule, very simple. Then let us see the rule number 2. Rule number 2 is related to the values which are less than 1. For values which are less than 1, in bracket less than 1. Okay, means they are in fractions. These values are in fractions, such as 0 point something. Okay, in this case all zeros after decimal point. What is the rule? All zeros after decimal point. All zeros after decimal point before a non-zero number. Before a non-zero number, or before a non-zero digit, let us say, are not significant. Are not significant. So this rule is explaining which zeros in which number are not significant. Mind well, not significant. What is the rule? All zeros after decimal point. This is the condition. All zeros after decimal point. But before a non-zero digit. Before a non-zero digit are not significant. They are not significant numbers. So that zeros are not significant. For example, 0.03. So what is the first condition? For values less than 1. This value is less than 1. Yes, it is less than 1 because it is 0.03. This value is less than 1. So first condition is fulfilled. Then all zeros. So how many zeros are there? 1, 2. Total zeros are 2. But what is the next condition? After decimal point. All zeros after decimal point. So this is the decimal point here. Okay. And after decimal point, how many zeros are there? Only 1. Before a non-zero digit. All zeros after decimal point. Before a non-zero digit. So this digit is a non-zero digit and this is 3. So this 3 is a non-zero digit, are not significant. So this 0 is not significant. This 0 is not significant. Mind well. So this 0 is already, we know that this 0 is not significant because this 0 is used only to express the decimal point. Okay, and this 0 is also not significant according to this second rule. Why? Because according to this second rule, in case of numbers which are less than 1, all zeros after decimal point and before a non-zero digit are not significant. So this 0 is also not significant. So in the number 0.03 or 0.03, the number of significant figures is only 1. Got it? Okay, by practice you can do it very fastly. This session requires practice. Okay, for number of, if you do this number of ways, then it is very easy to understand the concept. Okay, so 0.03, the number of significant figures is only 1, because this is a non-zero digit, and this 3 is only giving a valuable or meaningful meaningful idea about that result, about that particular number. Okay, because this 0 is used only to express the decimal point. This 0 is also not meaningful, because according to this rule, and this 3, which is a non-zero number, is meaningful only. So the significant figure in this 0.03 is only 1. Then take another example, 0.0068. You can take any number here. For simplicity, I have summarized all these rules on a paper for the better simplification or better explanation to you. Okay, so here again 0.0068, this value is again less than 1, and this is the decimal point. These two zeros are after decimal point, before a non-zero digit. So 6 is a non-zero digit. So after decimal point and before this 6 digit, how many zeros are there? 2. 1, 2. So these 2 zeros are not significant. This 0 is also not significant as per first rule. Okay, so all these 3 zeros are not significant, and remaining digits are 6 and 8. So 1, 2. So the significant figure in this case is 2. Okay, then take another example, 0.0771. 0.0771. Okay, you can take any number, 0.771, 0.893, 0.8946, 0.0523, any number, you can take any number. Okay, again this is a decimal point, this is non-zero digit. How many zeros are there? 1. So this is a non-significant. So significant figures are only 1, 2, 3. So this is 3. Okay, then 0.00 3691, let us say, or 2, any number. Decimal point, how many zeros are there? 1, 2. They are not significant. So the significant figures, this 3 is significant, 6, 9, 1, 2, all are significant. So how many digits are there? 1, 2, 3, 4, 5. So the significant figure in this case is 5. Okay, so this is the second rule about for the values which are less than 1, for the values less than 1. And this second rule is related to the number of zeros after decimal point, number of zeros after decimal point in values less than 1. Now the third rule is related to the for the values greater than 1. For the values greater than 1, then we have to find out the significance of the zeros after decimal point. Significance of the zeros after decimal point. In this case, all zeros before decimal point, all zeros here before decimal point are significant. That is, the zeros between are significant. Okay, the meaning of this is, that is, zeros between any non-zero numbers, any non-zero digits or numbers are significant. So the reverse of the second rule, this is for values greater than 1. For values greater than 1 or more than 1, for the values more than 1, all zeros before decimal point, are significant. All zeros before decimal point are significant. That is zeros. In other words, this rule can also be stated as zeros between any non-zero digits or numbers are significant. Okay, let us see examples. 2.00, any number, you can take here, you can take any number, suppose 52. 2.0052, as this number is 2.00 something, so this number is greater than 1. This number is greater than 1. Now this is the decimal point. Now after decimal point, how many zeros are there? 2. After decimal point, how many zeros are there? 2. So these zeros are significant. Mind well, these zeros are significant, means we cannot neglect, we cannot omit these zeros after decimal point. Or the other meaning of this rule is zeros, these are the zeros between any non-zero digits. So this digit is 2, non-zero, this digit is 5, which is a non-zero. So the zeros between these 2 and 5 are significant. They are significant. Okay, so that's why this 2 is significant, this 0 are also significant, this 5 and this 2 is also significant, and that's why the number of significant figures in this number is 1, 2, 3, 4, 5. Okay, what is the rule? For values greater than 1, yes, it is greater than 1. Then all zeros here all zeros before, instead of before here we have to write here after. All zeros after decimal point, all zeros after decimal point are significant. It is just contrast to the second rule, all zeros after decimal point are significant, because this is this figure is greater than 1 and this is a decimal point, and after decimal point these two zeros are there, but in this case both these two zeros are significant, and in other words these are the zeros between any non-zero digit. This is a non-zero, this is non-zero digit. So in any non-zero digit these two zeros are significant. If as per the previous rule, as per the second rule, if this figure is like this 0.0052, 0.0052, then as per second rule this value is less than 1. So this 0 and this 0, these three zeros are non-significant. But if this value is greater than 1, let us say 6.00 6.00093, 6.00093. So this is where this value is greater than 1, and after decimal point how many zeros are there? 1, 2, 3. All these three zeros are in between two non-zero digits. The first digit is 6, second digit is 9. So both are non-zero digits, that's why both digits, so all these three zeros are significant. So 1, 2, 3 all are significant, the 6 is significant, 9, 3 all are significant. So the significant figure for the 6.00093 is 1, 2, 3, 4, 5, 6. Okay, very easy. Then let us take one more example, 68.01. 68.01. Okay, so no doubt this is a non-zero, greater than 1, this figure is greater than 1. 68.01. We cannot omit, we cannot neglect this 0. This 0 is having some significance value. Okay, so that's why all these 4 numbers 1, 2, 3, 4 are significant. So the significant figures is 4, then 106.09. You can take any number. So again greater than 1, this figure is greater than 1, this 0 is after decimal point. Okay, and after decimal point, so this 0 is significant in nature. So 1, 2, 3, all the digits are significant. 1, 2, 3, 4, 5. So number of significant figures is 5 in this case. Okay, so very easy. Then this is the third rule. Let us see now the fourth rule. So the fourth rule, we will not write the fourth rule directly, but you will guess that rule, or you will get that rule by taking some examples. Okay, so take some examples. This is the rule number 4. Mind well, the content given in your book is so vast, so vague. So before reading that content in your books or reference books or any notes, kindly see this video 2 to 3 times. Kindly see this video 2 to 3 times to get the concept of significant figures and computation, because all the theoretical explanation given in your book is very vague and is very lengthy. So we cannot get that particular concept in easy steps or in easy way. Okay, so that's why I have summarized all this data, all this content on a paper, and then I am ready to explain you this concept. Okay, so the fourth rule is you will get this rule by taking examples. Okay, so the first example is 0.0400. Then 4.00, then 4.000, then 400, then 400.00. Okay, so instead of 4 you can take 2, 3, 4, 1, 9, 6, 5, any number. But for getting this rule, for getting this concept, let us see the magic of zeros in the concept of significant figures. This is the magic of zeros. Okay, now so as per the first rule, this 0 is non-significant. As per the second rule, this 0 is also non-significant, because this number is less than 1, and in less than 1 numbers, the number of zeros after decimal point, number of zeros after, immediately after decimal point, mind well, immediately after decimal point, this 0 is not significant. But as after this non-significant 0, we have a non-zero number, that is 4. We have a non-zero number, that is 4. This number is significant. This number is significant, and these two zeros are also significant. These two zeros are also significant. So we cannot neglect, we cannot omit these two zeros after 4. So these two zeros are also significant, and these two zeros are non-significant. So that's why number of significant figures in 0.0400 is 3. Okay, and what are these? 400, these three. Okay, next number is 4.00. So this is a non-zero number, as this is a 4.00, this is non-zero number. Decimal point is given here, mind well, decimal point is given after 4, and 4 is a non-zero number, 4.00. Okay, so though this number is a non-zero and this number contains 2 zeros after decimal point, all these zeros, both these zeros are significant. are significant. No doubt this 4 is also significant. So the number of significant figures in this 4.00 is 3. Similarly, 4.000, we cannot omit, we cannot neglect these 3 zeros. So for the significant figures, we have to consider all these 4 digits. 1, 2, 3, 4. So the number of significant figures are 4. Okay. Here number of significant figures are 1, 2, 3, 4, 5. Mind well, decimal point is given. Though the number is very small or very less, this is 4.00, 4.000, this is 400.00. Though the number is very small, 4 point something or 40 point something or 400 point something, if the decimal point is given and after decimal point how many number of zeros are given, all are significant. So 1, 2, 3, 4, 5, all these digits are significant. So the number of significant figures in this case are 5. But mind well, but in this case the number is 400 only. The number is 400. This number is greater than 1, but the decimal point is not given. Here. Okay, in this case this 4 is significant digit. This 0 and this 0 are not significant. This 0 and this 0 are not significant. Okay, so in case of 400, the number of significant figures is only 1. Okay, so this is the concept that we have to learn by practice. This is the rule number 4. This rule number 4 is again related to the zeros. So that's why these zeros are, sometimes they are after decimal point, sometimes there will be no decimal point, sometimes the number of zeros after decimal points are many, or in some cases they are few. Okay, so whatever the concept is there, from these points or from these examples you can get this concept of significant figures very easily. Okay, so this is all about the rule number 4. Then after learning these rules of the significant figures, we have to apply them for the addition and subtraction. Addition and subtraction. Let us see application of these rules in the addition or in the summation. Okay, and the application of these significant figures or rules in the addition, subtraction, multiplication and division, the 4 basic operations in mathematics. These applications, in short, we call them as computation. Okay, so the first operation is addition. Okay, we will see the rules summarized here before this addition in this concept. Okay, known as computation. Okay, we will see one by one. So take first example here. So you can take any example. This is taken only for your sake of simplicity. 43.1 plus 4.31 plus 0.431. So 3 numbers are given. 43.1, 4.31 and 0.431. Okay, now if you use a calculator or if you use your basic knowledge of your addition or summation, then the sum of this will be
0.1344134.8.340074004.
The sum, or in your calculator you will get this answer 47.841. Okay, but this answer or this addition, this summation is not correct as per the rules of significant figures and computation. As per the rules of significant figures and computation, this answer is not correct. Why? Because what is the rule? What is the rule? First of all, let us see the number of significant figures and number of decimal places in each of these numbers. So number of significant figures, I am writing in short, SF means significant figures, number of significant figures. So 1, 2, 3, all three are significant figures. 1, 2, 3, all three are significant figures. Here is also, this is a less than 0 number and there are no zeros, so this 4 is significant, 3 is significant, 1 is significant. So in all these three numbers, the number of significant figures are 3. 3 here, 3 here, 3 here. Okay. Now number of places after decimal point. After decimal point. So this is the decimal point. And number of places after decimal point, how many? Here only 1 in this case. In this number 4.31, how many places are there after decimal point? 2. And in this case, number of places after decimal point are 3. 1, 2, 3. Okay. So mind well, focus here. Now what is the rule? Rule is such that a sum or difference cannot have decimal points. This rule is very important. Cannot have decimal points. Cannot have decimal points more or greater than that number which has least number of decimal places. This is the rule. So what is the rule? A sum or difference means in addition or in subtraction, the result of addition or subtraction cannot have decimal points. More or greater as compared to more or greater than that number means the given numbers, then that number which has least number of decimal places. Least means the lowest number of decimal places. So we have 3 numbers here. Explanation of this rule. We have 3 numbers here. For this number of places after decimal point is 1. For this number of places after decimal point are 2. And for this number is 3. And according to this rule, the least number of decimal places, this number is this one. It is 43.1. In this 43.1 number of places after decimal point are least. Least means minimum. Lowest, it is 1. Here it is 2, these are 3. It is 1 here. So according to this rule, a sum or difference means the result of addition or subtraction cannot have decimal points. More or greater than the number which has least number of decimal points. So only one decimal point we can write after the only one decimal place we can take in our sum, in our answer of the addition. Why? Because in this case, number of places after decimal point in this number are 1. So we can write here only our correct answer is 47.8 only and not 47.841. Okay, so we cannot write 2 more places, that is 41. We cannot write 2 more places in this sum, in this answer. So this is the rule related to the addition significant figures and computation in the addition. Okay, so this is very simple rule. You see this video, what I am talking, what I am reading, what I am explaining here, then you will get the concept very easy. Okay, then take the second example of the addition. Rule will be the same. Second example is 0.0025, then plus 4.1167, 5.9071. Okay, so in these cases, number of places after decimal point are number of places after decimal point. So these are the decimal point. 1, 2, 3, 4. Number of places after decimal point are 4. Here 1, 2, 3, 4, again 4, and 1, 2, 3, 4, again 4. So the number of places after decimal point are constant here, or same, they are 4. But the number of significant figures are different here. In this case it is number of significants are only 2 here, because these zeros are not significant. Here it is 1, 2, 3, 4, 5, all digits are significant. In this case all digits are significant. So there is no any role of the number of significant figures in addition. Okay, let's just focus on number of places after decimal points. In all these 4 numbers, they are same 4. So there is no question of which number has the least number of decimal places, because all these 4 numbers have the 4 places after decimal point. Okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, isn't it? Okay, very easy. Then the answer of this is, you can use your calculator or do the sum, the 10.0263, 10.0263. Okay, so 5, 7, 8, 5, 7, 12 plus 1, 3, 13. Okay, so very simple addition is there. Now the answer is 10.0263. In this case, the number of digits before decimal point are greater than the given numbers. It is allowed. This is allowed, but number of decimal points should be 4 here. 1, 2, 3, 4 again. Okay, so it is allowed. Okay, and what is the significant figure here again? For example only, 1, 2, 3, 4, 5, 6. So all 6 digits are significant. Okay, so let us take the example number 3. Example number 3 for the addition purpose. 10.414. 10.414. After viewing this video, you can take any number and you can try to get the answer by using these rules. Okay, for your practice. 10.414 plus 0.0037 plus 9.02. Okay, here number of significant figures 1, 2, 3, 4, 5. Here 5. Number of significant figures, these 3 zeros are non-significant. Here is only 1. And in this case, number of significant figures are 3. Okay, now the number of places after decimal point, in this case 1, 2, 3, in this case 1, 2, 3, 4, and in this case only 2. Now what is the rule? Least number of decimal places. Which number has least number of decimal places? This number, and number is 9.02. This number is 9.02, which has only 2 places after decimal point. Okay, and hence the answer of this is only 19.43. If you do the calculation in your calculator or calci, the answer will be 19.43 4377. Why? Because your addition rule or your calci is also taking or calculating the addition of 0.0037, which is incorrect as per this rule, which is incorrect as per this rule. This is only incorrect, means this is only for the computation purpose. This is not a incorrect answer actually, but for the purpose of computation and significant figure concept, this is not considered as a correct answer. What is the correct answer as per this rule? Number of decimal points should be 2, because this number has least number of decimal points, 02, and while doing addition we will only consider the digits, 2 digits after decimal point, these two and these two, not this 4, not this 37. Okay, because this rule, number of decimal points 2, that's why we have not considered this 4 digit in this number, 37 in this number, and hence only we have taken the addition of up to this, and that's why the correct sum of these numbers according to this rule is 19.43. Okay, so in this way we can compute or we can apply the concept of significant figures on the addition and subtraction. So these are the examples of addition. Now let us see the examples of subtraction. They are very easy again. The same concept is, same rule is applicable there. Okay, examples of subtraction. Take first example. 44.341 minus 4.4432. Okay, difference. So what will be the difference here? Difference is 39 point, you can use your calci or you can calculate manually, 39.8978.